Manufacturing Insights, Manufacturing Engineering Magazine's video series for process improvement. This program examines the quality methodology Six Sigma and illustrates its impact on manufacturing and other business operations at Ortho Clinical Diagnostics, a division of Johnson & Johnson, where they believe Six Sigma will make them number one in their industry by helping to identify and create permanent solutions to any manufacturing problem. At Graytag Imaging, a photographic hardware manufacturer, where they say Six Sigma has been successful in improving customer satisfaction by helping to solve difficult logistical problems. And at Lockheed Martin's Government Electronic Systems plant, where they've saved nearly $3 billion over the last 3 years with a combination of Six Sigma and lean manufacturing programs. Six Sigma has been simultaneously called a revolution and nothing new. Indeed, many of the tools in the Six Sigma methodology are the same tools used in a number of other quality initiatives. The difference appears to be in the organization and application of those tools, the limited staffing requirement for its utilization, and its emphasis on specific fixed-length projects. The term Sigma comes from the Greek alphabet and is used in formulas to indicate variability. Sigma quality levels indicate how often defects are likely to occur. Higher Sigma quality levels indicate processes that are less likely to create defects. For instance, a 3 Sigma quality level is approximately 10,700 defects per million opportunities, while a 6 Sigma quality level is less than 3.4 defects per million. The definition of Six Sigma is not simple. More accurately, Six Sigma has several definitions. 1, it is a quality metric that can be used to compare processes. 2, it is a quality system that controls variation in products. 3, it is a philosophy that uses collected and tested data to make decisions. 4, it is an overall quality improvement and business strategy. And finally, Six Sigma is a problem-solving method that identifies root causes and helps determine permanent solutions. Six Sigma started at Motorola in the 1980s as a way of reducing defects and production cycle time. Practiced only in their manufacturing environments, management later estimated that another $5 billion could have been saved in the early years by implementing Six Sigma in the administrative as well as business areas of the corporation. Since that time, Six Sigma has improved the bottom line at several high-profile corporations. These organizations and others are implementing Six Sigma in manufacturing and transactional areas like sales, service, and shipping. The basic Six Sigma philosophy is that all processes, from design and manufacturing to customer service, show some variation, which can result in product defects that cost time and money. These process variations can be reduced by designing experiments to methodically and systematically identify the real cause of the problem. The result of controlling the variation can reduce scrap, defects, and repairs, while optimizing repeatability and efficiency. The typical implementation of Six Sigma begins with the training of a management leadership team. Key people are then trained in Six Sigma methodology and designated as green belts or black belts depending on their level of training. The number of green and black belts is determined by the organization. Completion of an actual project is a prerequisite of successful Six Sigma training. Six Sigma training teaches observational methods and scientific experimentation techniques. Experiment design and graphic methods of analysis and SPC are also included in the curriculum. The Six Sigma movement has its critics and its supporters, its advantages and its flaws, but it is delivering proven quality and cost improvements on all levels and in all aspects of business. Ortho Clinical Diagnostics, a Johnson & Johnson company in Rochester, New York, provides professional diagnostic products to hospital laboratories, commercial clinical laboratories, and blood donor centers. Its products include reagents used in blood transfusions, blood screening, and reagents and instrument systems for clinical chemistry.
You start seeing impact as soon as you start training your first wave of black belts, because they're going to start delivering business results immediately. In terms of getting the gain back from the training investment, really within 6-9 months you can really start putting money right to the bottom line.
The major benefits are a reduction in our waste bill, which is essentially a metric for quality. So our quality has improved, and as a result we're seeing less scrap. That's been one of the biggest things. Another thing is productivity. Before, reworking material is costing us a lot in terms of work in progress or downtime for machines. But now we're more of an even flow manufacturing facility, which fits into our lean principles too. It can be used for administrative types of processes. It can be used for auditing. It can be used in any application.
Workforce empowerment and management commitment both play critical roles in Six Sigma. Nevertheless, that does not translate to a requirement that the entire workforce has to be convinced to buy in, or even trained to make Six Sigma work.
It's got to be interwoven tightly into the organization, and it is a question of leadership and not buy-in. It needs to start from a relatively high level that understands the value of Six Sigma and has some understanding of what is required to really deploy it effectively throughout an organization.
The way employees are empowered essentially is we're providing them with a mechanism to generate data and use data to make decisions, and that's how you can make impact with management groups or leadership types, is that if you measure something and you can show data, that is how you can make decisions.
Management needs to be really invested in it so that they give their folks the opportunity to actually apply it. And without that, it does become another fad. And you can train everybody in the business, and if management doesn't actually let you use it, it's a big waste.
Training is an important part of a successful Six Sigma deployment, but everyone does not have to be a master black belt.
Here at OCD we have green belts go through 2 weeks of training and black belts go through 4 weeks of training. So that's really the differentiation that we see. The bottom line is they're problem solvers. So we've given them the tools to go out and solve problems that they run into on a day-to-day basis.
One of the really critical parts of that, however, is to know which tool to apply to what problem. So some projects, maybe all you have to really do is a process map, and lo and behold, you can understand what the problem is. In other cases, you may need to do a substantial amount of data mining or a substantial amount of experimentation to really understand what the source of the problem is and how best to fix it.
The core tools that we use for the main part are correlation regression, process capability studies, gauge capability studies. Many times we'll find that we think we have a defect, but it turns out to be measurement system noise. Other things, DOEs are a big part of it.
So a really big factor is keeping people from cause jumping.
OCD has learned through Six Sigma that some manufacturing problems can't be fixed by improving the process alone. Sometimes design changes, which are never simple, are required.
Design for Six Sigma has two basic goals. One is to delight manufacturing by delivering them a product and processes that they don't have to start fixing as soon as R&D transfers it to them. Another really critical part of Design for Six Sigma is delighting the customer. Really understanding what the needs of the customer are and what it's going to take to make them happy.
We can use the Six Sigma tool set up front in the design phase and identify those sources of variability and reduce the potential occurrence of defects in manufacturing.
The DMAIC process is at the heart of Six Sigma and gives it the structure that makes it work.
Define, measure, analyze, innovative improvement, we call it here at OCD, and control. Those are the 5 basic steps, and it's really a problem-solving process that the DMAIC process outlines.
And the first phase is define, where you essentially define your defect, define your business and customer impact. Then you go into measure, which is where you learn about your process. You map it, you list all your inputs and outputs. Then you go into analyze, which is where you say, okay, which ones are key variables? And from analyze, you go to improve, where you might do some DOEs or optimization experiments. Control those variables, find out where they need to be to develop, to give you optimal output. Then lastly, the most important phase is control. What are you going to do to make sure this failure mode never happens again?
Project orientation enables effort and analysis to be concentrated on the solution to specific problems. Solutions that are visible provide quantifiable results and, in turn, motivation to those involved.
Project identification is crucial. The way we go at identifying projects, we look at several things. One is, like we said before, we want to have financial results through these projects. So it has to be important to the organization. And that serves a dual purpose. One is we know that once a project's done, we will receive some sort of financial benefit back from it. The second thing, if it's important to the organization, it will be aligned with what we need to do for that month, that year, or any particular strategy we have.
That's one of the core principles of Six Sigma is breaking it down, sifting through all the process variables that are causing your defect or your variability, and rooting out the key ones so you can focus your project in those key areas and have an impact.
The use of the Six Sigma tool set enabled OCD to find and fix a persistent compressor problem on one of their diagnostic analyzers. At the same time, the methodology identified specifications issues with the vendor, the real cause of the problem.
We were having a defect or scrap rate of around 18% on that particular compressor, and compressors aren't cheap, so to have that level of defect is a financial burden on the organization. And through the use of the Six Sigma tool set, in fact, one of our black belts that went through the training used this as one of his projects to get certified. Went through, identified what the cause was, both from there was a discrepancy between the supplier and OCD as far as what the specifications were. We also found that the measurement systems we were using weren't adequate, and we were able to use that information and actually go out and redesign the compressor using a design of experiments to basically come up with a new and improved compressor design that had a scrap rate less than 5%.
OCD is obviously committed to Six Sigma and expects great things from it. Their implementation is aggressive and demonstrates their faith in the methodology.
Six Sigma and design for Six Sigma is what's going to make us the number one person in the number one player in our market. And that's where we want to be.
And ultimately, we want to deliver a product to our customer that is never defective. And for a business impact, ultimately we want to eliminate scrap and rework associated with product defects.
Six Sigma is viewed as a very powerful tool here, methodology within OCD, so we want to use it to drive business results.
Graytag Imaging in Holyoke, Massachusetts is a manufacturer of photo finishing and imaging systems and equipment. Its products and services include mini labs, central labs, internet applications, and software. They began their Six Sigma program about 2 years ago. Their Director of Process Management, Jim Markey, has a unique view of the methodology.
ISO 9000 was the rules, and Six Sigma gives us the tools. So rules and tools is an easy way to remember that. Six Sigma gives you analytical knowledge and understanding. It also gives you the soft skills such as project management, brainstorming techniques, change management, and so forth, for helping people understand, that this is not an efficiency job-cutting exercise. It's actually to help them improve their processes and make life easier for them.
Graytag uses Six Sigma in their manufacturing processes, but guided by their customer satisfaction goals, they have implemented Six Sigma in other areas as well.
One of the things that is somewhat unique here is that we're using Six Sigma quite a bit more in the transactional side of our business than we are on the manufacturing side.
In the customer service department, we're not making anything that you buy or sell. We are providing a service, flat-out service, and I've used the tools, I think, fairly well to find better ways to interface with the customers and interface with the rest of the company. There are purchasing, planning, accounting, all of those things.
Implementation of Six Sigma must be tailored to fit the organization. Small to medium-sized companies, such as Graytag, do not have the depth of resources that larger companies do.
The strategy here is to initially stabilize our processes. ISO 9000 is supposed to do that in theory, but again, it doesn't give you the tools to do that. So we were kind of like stumbling around blind in the dark until we came upon Six Sigma.
A program unlike TQM, where the notion was to spread the word for everyone within the organization, Six Sigma takes a much longer process in that you take a handful of folks initially. Here we've got about a dozen or so folks that are involved in Six Sigma initially that are spreading the word. They're learning the tools, they're getting people involved.
The general goal first would be to maximize the internal processes of your business, utilizing the DMAIC process, and it moves on outward to bringing the Six Sigma methodology to your vendors in order to maximize their service to you, and then eventually creating new processes that already have those measures and methodologies in place so that you can continue the improvement process.
The Six Sigma process enables objective problem solving by providing a controlled and structured approach through a number of statistical tools.
What happens oftentimes in a non-Six Sigma environment is you'll get a bunch of people get into a room and you're not in there 5 minutes, and people will start talking about what solutions they're going to come up with. Well, what are you going to do about this problem? Well, let's try this, let's try that, let's try this. They don't even know what the problem is yet. They think they do. They know what the symptom is, but they don't know what the problem is. So what they're doing is throwing solutions at symptoms, rather than causes. And it's a crapshoot. You generally end up tackling the wrong thing and just adding variation into your processes rather than solving the problem.
The thing about Six Sigma is that it's not, you want to take the people out of it. It's not the people doing the job, it's the process they're following.
One of Graytag's top projects is addressing a key customer satisfaction issue, a condition called store down. Customers are not able to process film for several days at a time if the right service parts are not sent out on time. When service parts are required, the field service technicians must make sure they order several specific replacement parts to get the machine up and running in less than 24 hours.
What Six Sigma has done is help define basically an operational definition of the customer's request. So in essence, what Six Sigma allowed us to do is take an objective approach to this and said, let's first define what our shipment schedule is based on the customer's request. Let's look at how well we do against that and look at where our weaknesses are. And it also pointed out that internally, if we had the parts, the customer our process was probably a 4.2 Sigma process. But from a customer's perspective, when things were on back order, it was probably down around a 3 Sigma process.
Six Sigma does incorporate a number of tried and true quality and statistical tools, but its overall method represents a new approach to quality, problem solving, and traditional techniques.
In American business, the firefighter has been rewarded. They're the heroes. They come in with their white horses and put out the fire. But those gains are oftentimes short-lived. And oftentimes they'll solve a problem in one department and that problem will just be squeezed out into another department.
Six Sigma promotes a deeper understanding of processes and the elimination of problems, allowing true continuous improvement. The reason and goal of its structured project approach is long-term improvement, permanent solutions to long-standing problems, and bottom-line efficiency.
Six Sigma allows you a template to look at it and have it become realized, to allow people that aren't working in the process that you obviously need the backing of, such as management, to actually see, without doing the job, what's going on.
These are generally problems that have been around for a long time and have had a variety of different solutions attempted, and in many instances they've only worked temporarily because they haven't really found the root cause of the issue. So the notion of it being a project that it has a start and an end is critical to the overall success of Six Sigma within any organization.
What makes Six Sigma successful where other initiatives fail?
You'd have 25% of your workforce that really excelled, 75% of your 50% of your workforce that maybe did so-so, and 25% absolutely failed dismally at the TQM effort. What that caused was a lot of discontent, a lot of resentment, and I think it was rejected because that's one of the reasons. The other reason is there was not a clear enough top-down driven philosophy with TQM. It was a little bit looser than Six Sigma. There was also no reference to the bottom line, and that's probably the biggest reason why Six Sigma is successful.
Lockheed Martin manufactures advanced military equipment and systems. Their government electronic systems plant in Moorestown, New Jersey, produces hardware, software, and systems integration for the Navy. They have been implementing the Six Sigma methodology in combination with lean practices for 4 years across a corporation of about 125,000 people with 30 major sites across the United States.
Our philosophy of using Lean and Six Sigma is to do it throughout the whole enterprise. We've got projects in our human resource department, we've got projects in our finance department. We even try to practice what we preach and use the tools on us so that we improve our training over time and our delivery.
Looking at it with both Lean and Six Sigma as tools in your toolkit, it just provides more capability for you to improve your processes.
Implementation strategy in a company as large as Lockheed Martin is a massive undertaking. Identifying the right projects is still critical. Getting the word out and clearing resistance is fundamental. But equally important is the simultaneous initiation of process analysis and the Six Sigma methodology.
I'm one of 17 consultants that we have working for our corporate staff to help spread Lean and Six Sigma across the corporation. They're there to help break down the barriers. You also have to have some kind of leadership council that determines what projects to work on. At the same time, you got to get the activity started. At the very basic, we're trying to understand how we do work. How do we process invoices? How do we do an operation on the manufacturing floor? Really understanding how we do it and looking at it in terms of waste.
We're picking projects and picking improvement opportunities that are really critical to the business. They align with our strategic plan, and they also are key indicators for success for Lockheed Martin in the future.
Projects and events are highly important for a Lean Six Sigma deployment. They focus the activity so that you can start with an objective and focus the resources and get that objective done in a key time frame.
Permanent solutions to problems and reduced process variability are direct results of Six Sigma, but so are other secondary benefits as well.
It also improves the capability of your workforce. It's getting the knowledge into your workforce and having your workforce think about achieving solutions to problems using that toolkit and the tool set.
We get them involved in every project, every Kaizen event that we can, because they're the ones that do the work. They understand what it takes to improve that area. A lot of times we'll bring the black belt in who has the skills and the knowledge and the tools to be able to sift through the data. But again, when it comes up to time of brainstorming, it's usually the workers that come up with the best ideas.
While a Kaizen event is not a standard Six Sigma practice, Lockheed Martin finds them useful and needed. It's a good example of the tailoring that must be done to make Six Sigma integrate with other process improvement initiatives.
There is no one set recipe that's going to work for every business. You will inevitably have to tailor some of your training techniques and materials to apply to the types of processes that you work with. As far as tailoring, just utilize a relative approach and get people engaged up front and find out the types of problems that they're struggling with.
Lockheed Martin is using Six Sigma in transactional areas as well as manufacturing. They've used a phased approach to implementation and learned that being over-enthusiastic can be as counterproductive as resistance to change.
Engaging your top-level management and providing a core level of knowledge into the business, that might be your first phase. Your second phase might be picking out your first initial targets and defining the scope of these targets. The third phase will be obviously training your teams to create the body of knowledge in your business. And the next phase would be certainly deploying and measuring your results.
In terms of deploying it, the one warning would be not to get so excited about the tools and the process and lose sight of what you're actually doing in a business. A lot of times we train our black belts, they know the tools in and out, but as they come in and try to make a change in their area, they just don't even understand what that product's about and that service is about. We're here to serve what we do here, and that's to get our products and services out the door.
Lockheed Martin's Six Sigma program is extensive and long-term. They've seen immediate returns on their investment, and they've learned through experience what it takes to make it work. Here is their advice to companies thinking about Six Sigma.
I would encourage your companies not to rely on consultants. I would encourage you to create your own internal body of knowledge, because these people will become your experts.
But you got to be careful, because if you just rely on the black belts and green belts, a lot of times people will say, well, they're doing the changes, I don't have to. To really get the culture change you want, you got to get everybody involved on it. One of the key things we try to do at Lockheed Martin is get everybody to see something that's wasteful, be able to call it waste, and be able to get rid of it.
Any process can show variation that can cause problems, waste, and inefficiency. Six Sigma's observational problem-solving methods identify root causes of those problems and are then used to determine permanent solutions. The methodology is project-oriented, which provides a beginning and end feature, delivering rewards that make Six Sigma meaningful and profitable. Designed for Six Sigma, a relatively new aspect, is being used to identify and prevent design flaws before they can become part of a process. Six Sigma is proving to be as advantageous in transactional areas of companies as it is in manufacturing. Six Sigma can provide immediate returns when implemented properly.